describe a combined variation. This is a combination of all the variation types that we had learned, namely direct, inverse, and joint. Remember, for direct, we have varies directly. That would be y is equal to kx. For inverse, varies inversely or inversely proportional to, we have y is equal to k over x. And for joint variation, we have more than two variables involved or two quantities involved. If we have varies jointly, we can have y is equal to k x z or more variables. These are some of the combined variation real life examples. W varies jointly as x and y and inversely as z. Now, if we're going to write this is equal to varies jointly, so we are going to have the constant of variation k with the variables x and y because they are joined. And inversely, we will put that in our denominator z. This is now our formula for, or the equation for the given mathematical statement. Now let us derive for the value of k. So to solve for k, we have w is equal to k xy over z. Okay? Remember, we are just going to derive this from the equation that we have. So, we'll cross multiply, we'll have this. So, wz is equal to kxy. And we need to remove or eliminate the two other variables beside k. So, we will multiply both sides with 1 over xy. Then, this will be cancelled because xy over xy is equal to 1. And what we have left on the right side is k times the 1. So, that would be k. And on the left side of the equation, we have 1 over xy times wz will be wz over xy. This will be our formula for the constant of variation. That is just the same when we rewrite it as k is equal to wz over xy. This will help us solve for the value of the constant of variation. These are the terms that we will use in combined variation. Varies directly as b. That would be a direct variation. And inversely, we put it in the denominator c. For the second given, we have y varies jointly as x and z and inversely as w. That would be y, constant of variation, jointly x and z, and inversely as w. That's how we're going to write it. The volume of gas varies directly as the temperature and inversely as the pressure. So let us assume variables. Volume of a gas varies directly as the temperature T and inversely as the pressure over P. Number of phone calls, C, per day between two cities has found to be jointly proportional to the populations of the two cities P1 and P2, and inversely proportional to the square of the distance D between the two cities. So let's take C varies jointly with P1. Don't forget the constant of variation, P1 and P2, and inversely proportional with or to the square of the distance. So we have the D squared. Then that is our equation. Varies directly as the square of P and inversely as Z. T varies directly, don't forget the constant, as the square of P. So that means P squared. And inversely as Z. This is our equation. So let's find the constant of variation and rewrite the equation. So to find K, again, we will derive this equation. That's P squared over Z. Cross multiply, we'll have this Tz is equal to Kp squared. After that, we will continue by removing the the variable beside K. That would be 1 over P squared. 1 over P squared. So this will be cancelled. That's equal to 1. And then 1 times K is equal to Tz over P squared. Now, our formula for constant of variation will be Tz over P squared. Solve for the value of K. Let's simplify the denominator with an exponent. So that would be K is equal to 72 over 3 squared, 9. Way of solving, let's say that's K is equal to 12 times 6 over 9, 3 squared. So we can just use cancellation if they have GCF. So 12 and 9 are both divisible by 3. 12 divided by 3 is 4. And then 9 divided by 3 is 3. And then we can also, again, cancel 3 and 6. 6 divided by 3 is 2. And 3 divided by 3 is 1. Now, what do we have for our value of K? Multiply the numerator. 4 times 2 is 8 over 1 is just the same with 8. These are two solutions, two ways of solving, and still you get the same answer. Let us rewrite our equation. That would be from the original equation that we have here. So this will be T is equal to 8P squared over Z. This is now the equation of our given problem. Z varies jointly as Y and W and inversely as the square of X. As you see, we have jointly. So we will write the equation. Z varies jointly, meaning we will multiply this with our constant of variation, y, w, and inversely as the square of x squared. So this is z. Okay? Then, let's have the solution for formula for the constant of variation. We derive z equals kyw over x squared. We multiply this. So we have x squared z is equal to kyw. Then we are going to eliminate the variables beside k. To find k, we multiply 1 over these two variables, yw, on both sides of the equation. Then we cancel, is equal to 1, k times 1. And then on the left side, we have 1 times x squared z is x squared z over yw. So this will be our formula in finding k. Let's just rewrite. K is equal to x squared z over yw. After finding that, now we can continue solving for what is asked. Identify the variables. We have z is equal to the value, 360. Y is equal to 24. W is equal to 20. X is equal to 4. After identifying all these values, we can substitute to find the value of k. X is 4 squared. Careful with substitution. Z is 360 over y, 24 times w is 20. Okay. So, let us simplify this. We have 4 squared is equal to 16 times 360 over 24 times 20. We may multiply everything together, but it's easier if we will use simplifying or cancellation to make the given numbers smaller. Okay, so 360 divided by 20 is 18. Then next we have 16 and 24 are both divisible by 4. 16 divided by 4 is 4. 24 divided by 4 is 6. And then finally, 6 and 18 are 18 can be divided by 6. So this is 1 and this will be 3. Now, what do we have for k? In the numerator, we have 4 times 3 is 12. And in the denominator, we have 1. So the answer is k is equal to 12. After finding k, now we can rewrite our formula by substituting the value of our k. So k is 12. Here, our formula will be z is equal to 12yw over x squared. Again, this will be our formula for the given problem. If p varies directly as the square of p and inversely as the square root of r. Okay, let's write it. So we have p varies directly So, as the square of q, so we have q squared. And inversely, as the square root of r, so the square root of r. So, our equation will look like this. And then, we need to find the equation for finding the value of the constant before we can proceed to finding the value of what is asked. So, let us derive again. That's p is equal to k q squared over the square root of r. We cross multiply. Then we'll have p square root of r is equal to k q squared. And then we will simplify by removing the q squared beside k by multiplying 1 over q squared on both sides of the equation, and that would be cancelled. That's k now is equal to p square root of r over q squared. So we will just rewrite it. Our formula for constant of variation is p square root of r over q squared. Okay, then let us solve for k by taking the variables and its values. So we have p is equal to 60, q is equal to 6, r is equal to 81. Let's substitute. K is equal to 60 times the square root of 81 over q squared is 6 squared. Then let's simplify. That's k is equal to 60. Square root of 81 is 9. And then 6 squared is 36. Now let us simplify. Let's use cancellation. So 9 and 36 are both divisible by 9, 1, and then 4. Next, 4 and 60 are still divisible with each other. 60 is divisible by 4. So 60 divided by 4 is, this is 1 and this is 15. So in the numerator, we have k equals 15 times 1. 15 in the denominator is 1. That's also 15. K is equal to 15. Now let's change the equation. That would be P is equal to 15 Q squared over the square root of R. Okay, we're going to look for P when Q is equal to 8 and R is equal to 144. Now we substitute. We have P is equals to 15 times 8 squared. Let's not forget the squared. Over square root of 144. Then we simplify. So that would be P is equal to 15 times 8 squared is 64 over the square root of 144 is 12. Then we simplify. We may use cancellation. Let's use 15 and 12. Both are divisible by 3. This is 4 and this is 5. Now, 64 and 4. 64 divided by 4, this is 1 in the denominator and 16 in the numerator. So P now is equal to 5 times 16, which is easier to multiply than having a big number, 15 times 64. And then in the denominator, we have 1 left. So the value of our P is 80. For our word problem, we have the number of T minutes needed to solve an exercise set of a variation problem N varies directly as the number of problems and inversely as the number of people working on the solutions. It takes 4 people 30 minutes to solve 18 problems. How many minutes will it take 6 people to solve 42 problems? Let's have first the equation for that. So it says T is needed to be solved varies directly. So we have K, N with a number of problems, and inversely with the number of people. So that's P. Of course, step 1, we need to derive the formula for K. So that's T is equal to Kn over P. This will be Tp is equal to Kn multiply both sides by 1 over n. K is equal to Tp over n. Or we can rewrite K is equal to Tp over n. This is our formula for finding the value of our constant of variation, and then we will substitute each given variables and its value. So T is given as 36. We have N is equal to 18 and P is equal to 4. Now let us solve for the value of K by substituting each value to our equation. K is equal to 36 times 4 over 18. Then we simplify. I'll use cancellation. 18 and 36. This is 1 and 2. K now is 2 times 4 is equal to 8. After finding K, now we can change the equation. It is now T is equal to 8n over P. How many minutes? So we're looking for the time given people is equal to 6 and the number of problem is equal to 42. Okay, let us solve. Substitute. We have to find T, 8, the constant of variation, times 42 divided by 6. Now what is this? So we can cancel 42 and 6. This is 1, 7. Now is equal to 56. So the time is 56 minutes. Final answer. Answer is 56 minutes to solve 42 problems for 6 people.